Basic operations on complex numbers. Addition. First is addition. Let z1 is equal to a plus iota b and z2 is equal to c plus iota d be two complex numbers and a, b, c, d belong to R. The sum of two complex numbers is given by z1 plus z2, which is equal to a plus b iota plus c plus d iota, and a plus c plus b plus d iota. This is the real part of these two numbers and this is the imaginary part of these two numbers. So at the end we learn that the sum of two complex numbers is the sum of the real part and imaginary part of these two complex numbers. Multiplication. Let z1 is equal to a plus b iota, z2 is equal to c plus d iota be two complex numbers. The product are found as: first, if k is the scalar belong to real number and k multiplied by z1 means k into a plus b iota. After simplification we have k a plus kb iota. This is the multiplication of complex number with a scalar and k is scalar. Second is z1 multiplied by z2. The product of these two complex numbers is ac minus bd plus ad plus bc iota. Multiplication of two complex numbers. Third operation is subtraction on complex number. Let z1 is equal to a plus iota b and z2 is equal to c plus iota d be two complex numbers. The difference between two complex numbers is given by z1 minus z2 equal to a plus b iota minus c plus d iota. After subtraction we have a minus c plus b minus d iota. That is, the difference of two complex number is the difference of the corresponding real and imaginary parts. Fourth basic operation is division. Let z1 equal to a plus b iota and z2 is equal to c plus d iota be two complex numbers such that z2 is equal to 0. The division of a plus b iota and c by c plus d iota is given by z1 divided by z2, a plus b iota divided by c plus d iota. Now we take the conjugate of this denominator and multiply by numerator and denominator such that a plus b iota over c plus d iota multiplied by c minus d iota, c minus d iota. After multiplication we have ac plus bc iota minus ad iota minus bd iota square c square minus d iota whole square. This is the difference of two square. Then we have ac plus b iota minus ad iota plus bd iota over c square plus d square. Iota square become minus 1 minus 1 minus 1 equal to plus, so it become, this term becomes positive due to iota square. Then we simplify it into this form: ac plus bd plus bc minus ad iota over c square plus d square, which can be written in the form of complex number which is ac plus bd over c square plus d square plus bc minus ad over c square plus d square iota. Exercise 2.6, question number 1. Identify the following statements as true or false. First, square root of minus 3 multiplied by square root of minus 3 is equal to 3, which is false. Second, iota with exponent 73 is equal to minus iota, which is false. Third, iota 10 equal to minus 1, true. Complex conjugate of minus 6 iota plus iota square is minus 1 plus 6 iota, true. Fifth, difference of a complex number z is equal to a plus b iota and its conjugate is a real number. It is false. Sixth, if a minus 1 minus in b plus 3 iota, we have 5 plus 8 iota, then a is equal to 6 and b is equal to minus 11, true. Seventh, product of a complex numbers and its conjugate is always a non-negative real number, true. Question number 2. Express each complex number in the standard form a plus b iota, where a and b are real numbers. First part, 2 plus 3 iota plus 7 minus 2 iota. After simplification, we have 2 plus 3 iota plus 7 minus 2 iota and combine the real part with real part and imaginary part with imaginary part. Then we have 2 plus 7 plus 3 iota minus 2 iota. After simplification, we have 9 plus iota. Second part, 2 into 5 plus 4 iota minus 3 into 7 plus 4 iota. Multiply these scalar with the complex number, then we have 2 5 the 10 and 2 4 the 8. Minus 3 7 21 minus 3 4 12 iota, minus 12 iota. Then we have the expression 10 minus 21 plus 8 iota minus 12 iota, which is equal to minus 11 minus 4 iota. Answer. Third part can easily be solved accordingly. Part 4 of question number 2. 2 iota square plus 6 iota cube plus 3 iota 16 minus 6 iota 19 plus iota 25. After simplification, we have 2 minus 1 iota square become minus 1. Iota cube can be written in this form, iota square multiplied by iota. Iota 16 can be written in this form, iota square with exponent 8. 8 iota 19 can be written in this, iota 18 multiplied by iota. Iota 25 can be written in this form, iota 24 multiplied by iota. So can we convert them into iota square. Therefore, iota square is equal to minus 1, iota square is equal to minus 1. We split further this exponent, that is iota square with exponent 9 into iota. Iota raised to power 24 can be written in this iota square with exponent 12 into iota. So this iota square becomes minus 1. This iota square becomes minus 1, this iota square becomes minus 1. After simplification of this expression, we have minus 2, minus 6 iota 3, 1 becomes positive due to this even number. Then iota square it becomes minus 1 and minus 1 remains minus 1 due to the odd exponent, and minus 1 of this becomes positive 1 due to the even exponent. Therefore, we have minus 2 6 minus 6 iota plus 3 plus 6 iota plus 4 iota. 6 iota and minus 6 iota are cancelled. Then we have after simplification 1 plus 4 iota, that is answer. Exercise 2.6. part 1 of question number 3. Minus 7 plus 3 iota into minus 3 plus 2 iota. Expanding them, we have 21 minus 14 iota minus 9 iota plus 6 iota square. So we have 21 minus 6 minus 23 iota. After solving this, answer is 15 minus 23 iota. Part 2, 2 minus iota, 2 minus square root minus 4 into 3 minus square root minus 4. Take out the minus sign and we have 2 minus square root 4 square root minus 1, 3 minus square root 4 square root minus 1. Square root minus 1 is equal to iota and 4 is the square root of 2. So new expression is 2 minus 2 iota, 3 minus 2 iota. After expanding this expression, we have 6 minus 4 iota minus 6 iota plus 4 iota square. Solving this, 6 minus 10 iota plus 4 minus 1 iota square is equal to minus 1. 6 minus 10 iota minus 4. After simplification, 2 minus 10 iota, which is the answer. Part 3 and 4 can easily be solved. Question number 4. Simplify and write your answer in the form of a plus b iota. First part, minus 2 over 1 plus iota. Take the conjugate of the denominator, that is 1 minus iota, multiply and divide it with this expression. So we have minus 2 into 1 minus iota, 1 plus iota into 1 minus iota. Now simplify them. We have minus 2 plus 2 iota, difference of 2 square, 1 whole square minus iota whole square, minus 2 plus 2 iota, 1 minus 1 iota square is equal to minus 1. So we have minus 2 plus 2 iota divided by 2. Take the common from the numerator 2. Then cancel 2 with its denominator. So the answer is minus 1 plus iota, which is in the form of a plus b iota. Therefore, part 2, 3 and 4 can easily be solved. Question number 5. Calculate a, z bar, b, z plus z bar, c, z minus z bar, d, z into z bar. First part, z is equal to 0 minus iota. A, z conjugate, take the conjugate of z, that is 0 plus iota. In b, we have to find out z plus z bar, that is 0 minus iota plus 0 plus iota. Cancel minus iota with plus iota, we have the answer 0. In C, we have to find z minus z bar, which is equal to 0 minus iota minus 0 plus iota. We have 0 minus iota and minus iota. So add minus iota, then we have z minus z bar is equal to minus 2 iota. In D part, we have to find out the product of z into z bar, that is minus into minus 1 and 1. The product of z into z bar is 1. Remaining parts can easily be solved. Question number 6. If z is equal to 2 plus 3 iota and w is equal to 5 minus 4 iota, then show that conjugate of z plus w is equal to conjugate of z plus conjugate of w. Take the left hand side, that is conjugate of z plus w. First of all, we have to find out the sum of z and w, that is 2 plus 3 iota plus 5 minus 4 iota, which is 7 minus iota. So take the conjugate of z plus w, that is 7 plus iota. Now right hand side, which is z bar plus w bar. So after taking the conjugate of z and w, we have 2 minus 3 iota plus 5 plus 4 iota. Conjugate of 2 plus 3 iota and 5 minus 4 iota. After simplification, we have 7 plus iota, which is equal to conjugate of the sum of the z plus w. So left hand side is equal to right hand side. Part number 2, 3 and 4 can easily be solved. Fifth part of question number 6, which is 1 over 2 into z plus z bar is the real part of z. Take z equal to 2 plus 3 iota. Conjugate of z is 2 minus 3 iota. The real part of z is 2, which is statement number 1. We have to solve this. 1 over, that is 1 over 2 z plus z bar equal to 1 over 2 plus 3 iota plus 2 minus 3 iota. After cancellation, we have 1 over 2 into 4. 2 cancel the 4. So the answer is 1 over 2 z plus z bar is equal to 2, which is the statement number of 2. From 1 and 2, 1 over 2 into z plus z bar is equal to real part of z, that is 2. Hence 1 over 2 into z plus z bar is equal to the real part of z. So this is what we have to prove. Part 6 can easily be solved. Question number 7. Solve the following equation for real x and y. Part 1. 2 minus 3 iota into x plus y iota is equal to 4 plus iota. Solution. 2 minus 3 iota into x plus y iota is equal to 4 iota. After simplification, we have x plus y iota is equal to 4 plus iota over 2 minus 3 iota. 2 minus 3 iota is multiplying on left hand side. When it goes to the right hand side, it becomes a denominator of 4 plus iota. Take the conjugate of 2 minus 3 iota, which is 2 plus 3 iota, multiply and divide with this expression. We have 4 plus iota into 2 plus 3 iota divided by 2 minus 3 iota into 2 plus 3 iota. After simplification, we have 8 plus 12 iota plus 2 iota plus 3 iota square divided by 2 whole square minus 3 iota square. Then we have 8 plus 14 iota plus 3 into minus 1, 4 minus iota square, which is equal to minus 1. After simplification, we have 5 plus 14 iota divided by 4 plus 3, 9, that is 13. So we have the expression x plus y iota is equal to 5 over 13 plus 14 over 13 iota. Then we have the answer x is equal to 5 over 13 and y is equal to 14 over 13. The remaining parts of question number 7 can easily be solved.